We're now going to take a look at 2D machining. Now you can either do this within the 3D view or the 2D view. It doesn't make any difference. I personally like to do this in the 3D view because what I can do is rotate this around and I can actually see the depth that it's actually cutting to. The first thing that we're going to do is create the pockets for this. So if we select the large phone rectangle and also select this rectangle, select toolpaths, and under the 2D toolpaths we have area clearance toolpath. This already uses the selected vectors. So the finished depth, let's say 8mm, and add a tool. This opens up the tool database and it will originally open up like this. Open up metric or inch tools depending on what tools you have. Going to open up metric, going to open the wood or plastic ones, and I've got roughing, 2D finishing, 3D finishing, V carving. And what I'm going to do is create this using, let's say, a 10mm end mill. Click select. If you want to see what the parameters are for this, just select the end mill here and it will open them up. You can change the step down if you like, 6mm. Let's say that that's maybe a bit too harsh. Let's change it to 3mm. You can change the strategy of this. So raster will basically come across in X, step over in Y, or you have the offset, which will follow the actual shape of this and then offset inwards. Come down to the bottom, set up the material. Let's make that 12mm thick. Select OK. Now that will take you back to the plan view. That's because it's set up the material. So if I rotate around again, you can see that I've got this material set up, which is 12mm thick. I can click calculate now and it will calculate the toolpaths for me. So I can then close that. Now if I were to simulate this, you should see that I'll have two pockets. So there you can see the two pockets. So let's delete this. Turn on the vectors again and you can see the toolpaths there. Now what I'm going to do is create another pocket. This is going to be for the lead. So let's go back to toolpaths and select area clearance toolpath again. The finished depth, let's say 5mm for this, and add a tool, let's say a 3mm end mill. Again, I'll do this as an offset and then select calculate now. Now I know that I'm going to have a problem at the top here. I'll show you how you can edit the toolpath afterwards. So let's close that. Now if you want to turn these toolpaths off, just select the light bulbs next to them like so, and it will turn them off so you don't actually see them. Let's cut these two areas out. So let's select both of those, create a profile toolpath this time. This is going to be on the inside. The finished depth automatically goes to the depth of the material. Select a tool, let's use the same 10mm end mill. And then click to calculate now. Or you can add a bridge to this so it holds it in place so the material doesn't fly out. So if I select add bridges, let's add, let's say 2 of them to each part. Let's do 3D bridges. Don't want these to be too wide or high. And then select add. You can see that it's added these bridges. Now if I wanted to move those, select edit and I can just move them to wherever I want. So let's say that I wanted these ones to be here. I can just move them around. Then I can close the edit bridges and then select to calculate now. Finally, what I need to do is to cut the parts out. So if I select this part and this part, I know that I'm going to have a problem here because this part on the left is an open vector. So I'll show you how you can sort that out. So if I create a toolpath and then create a profile toolpath, automatically is assigned to the outside. Automatically the finish depth is 12. Profiling tool, let's use a 10mm end mill again. Not going to add bridges for this one. And then select calculate now. Now what it's saying here is that I've got a closed vector here, but I've got an open vector here. So it does machine it, but it won't machine the area that's inside because it's not selected. So what I need to do is select this vector here, press shift and select that vector there, and then what I can do is join these together. And I can do that here by using the join vectors with coincident nodes. This just basically joins the vectors together. So if I select that, just move this out of the way, and then select join, creates one vector. So now if I calculate this, you can see that it's calculated without a problem. Okay, so now if I simulate all of these toolpaths, I should have my phone docking station. Okay, that looks quite good. It's left these two pieces in so they don't fly out of the material. The only problem that I've got is at the top here, you can see that I've got this rounded edge and it's quite sharp. So that might be a problem with the cable fitting in there. And that's because I've not let the tool come out far enough from the material. So what I'm going to do is turn on the vectors and then let's node edit this. I can either cut there and cut there, or I can just right click and remove span. So it just completely removes the area on the inside. And then what I can do is create a line. I'm not going to draw smooth polylines. Make sure that I add to existing line. And I'm just going to bring that out like so. And then if I recalculate that, so it's this second area clearance, edit that, and then I can just calculate it again, and then I can simulate just that one again. You can see that it's gone past the edge there. Now if I want to, I can delete the waste material. You can see that it's left these two areas because they're still held into the block. And you can see my finished mobile phone docking station.